John Tav, EIS. We're going to talk about using the right tool for the right job. I heard a lot of mention of this earlier from, I guess, the first presentation all the way to the Matt Bird discussion panel. It is a big deal. Good. All right, thank you. All right, it is a big deal. So that's what my presentation is going to be about. That's me. Background in computer science. I've been at EIS for 10 years. Started as a mechanical designer. Got into technology, and basically we formed our own technology department in 2019. So EIS is a full-service engineering design inspection firm with a technology division. Sorry about that. So the reason we formed the technology department or the division is to be able to explore and research new and implement new and practical solutions into our daily workflow. Here's an overview of our services. We got project development, project execution, inspections, reliability, commissioning, and startup. All of those, except the technology, is in the petrochemical market, mainly. Technology is where it kind of goes into petrochem, architecture construction, disaster recovery assistance, so on and so forth. Under the technology umbrella, we have 3D laser scanning or reality capture, modeling animation, virtual job planning, turnaround planning, and so much more. So some of the things that we have been implementing into our clients' workflows and our workflow is basically with the reason of improving the efficiencies. We have been using a lot of different reality capture tools, which we will talk about over here, for industrial, architecture, construction, disaster recovery, accident reconstruction markets. We started utilizing virtual reality with these tools. So basically from starting with capture, modeling, and all the way to visualizing in VR, that's something that we started doing. Also, operator and safety training in virtual reality is a big key thing that we use mobile scanning for. In addition, we do turnaround planning and motion amplification through use of different types of cameras. All right, so since we are an engineering firm that's mostly focused into one big market, we decided that having a separate technology brand, separate a subsidiary company, would be the way to go to have all the technology stuff under one umbrella. That is basically, as it pertains to capture, animations, modeling, all that stuff. So from this year and on, we're gonna start using this name, Captura, going forward for all the tech services. All right, we had to come to the reality capture part, right? So here is what we currently use in the reality capture, I guess, environment. So from left to right, we have metrology-grade scanners to aerial, which is basically the most accurate or the highest accuracy, fidelity, whatever you want to call it, to the least accuracy or tolerance. So metrology-grade, it is limited use, but it is 9/10,000ths of an inch accuracy. So it is used for reverse engineering, part verifications, inspection type stuff. You can capture objects up to 25 feet in length, so that is a limitation, but there are not too many things that you capture with this that's bigger than 25 feet. So the output of this is something that you can bring into a CNC machine, 3D printer, so if you want to replace an obsolete part, this is the type of capture device that you would use. Then terrestrial, I'm guessing everyone over here knows what it is. It's the typical tripod scanner that spins for multiple minutes. Your accuracy is gonna vary by brand or quality and resolution, but typically 1/16th of an inch to 1/8 of an inch is where it lives. Mobile scanning, that is the kind of like the new shiny tool that that everyone started seeing. So we currently have 5 NavVis VLXs. One of the largest fleets in the US with that. And we love that device. So it's extremely accurate, for what it is. It's not terrestrial scanner accuracy, but it's still high accuracy. It saves a lot of time when you're capturing large areas, buildings. It is the tool for most of those. Virtual tour imaging is a Matterport camera, so it's not a laser scanner, but it's still a capture device. High quality imaging, and it's great for virtual tours for real estate market. And since the first four that we showed, it's ground-based capture, you gotta top it off for for those jobs that you have high buildings or structures, or really large areas that you gotta capture. You have to use drone aerial services for that. So that's a chart that we use for kind of determining what capture is needed, or we give it to our clients. Okay, I think the clicker is not working. Can we switch it from up there? Thank you. All right, so the main idea is using the right tool for the right job, right? How it works is basically, if you pick the right tool, it'll give you, or the return that you get is going to be cost savings. There's going to be gained efficiencies by doing it one way versus the other. Reduce safety risks. In some cases, you might be exposed to safety hazards longer than if you don't have to, especially, you can eliminate those. Reducing rework. Some of the trade-offs, and the big one is going to be capture speed. So in terms of decisions on what type of capture device that you want to use, you got to look at the accuracy that you're getting on one side and the speed that you're getting on the other side, right? It's kind of counter, I guess, interactive. So you want the faster one, it's not going to be as accurate. You want the most accurate one, it's not going to be the fastest. So, but not every job requires the extreme accuracy or precision or fidelity tolerance, whatever you want to call that. So if it's going to take 10 times longer, but I'm going to get a decent accuracy, I might go for another option. And that is going to be mostly dependent on the job scope, the accuracy, and the deliverable needs that is dictated by the client. Another thing that comes into effect or play is the hardware-software complexity. So if the end user doesn't know what to do with a point cloud file, right, they don't have the software, the means to open it up, then you might look into delivering the same thing with web viewers or cloud-based viewing systems. So that comes into play for virtual walkthroughs especially. So web viewers are critical for that. And the other thing is, it kind of goes with the second one, the web viewer, the imaging, the capabilities, quality, the end user experience goes into what platform do we use to deliver this data to the client. There are a lot of cloud-based platforms, and every manufacturer typically has one that is native to their files. So, whether it's IBM, Cintu, or VRM. And we tested all of those so far, and you gotta pick the right one for the right job again. Some of the markets that we're currently in with types of scanners is kind of listed right here. So industrial is our main game, is our bread and butter, especially on the engineering side. That's been what the company has been doing for 20 years. So oil and gas, planning, maintenance, engineering, design, they can be all captured with these tools, along with facilities mapping or factory mapping. So the only tool that we don't really use for that is Matterport, just it's not there for that. Architecture construction, when it comes to commercial or residential, or if it's design, architecture purposes, or just general building capture. We use pretty much everything that's Faro, or terrestrial scanning, mobile scanning, and drone. Matterport has some, I guess, space in this, but nothing crazy. It's, we like to stick with real estate for that one. Disaster recovery assistance. So since Hurricane Ida last year, since we're a company based in Louisiana, we were affected by the hurricane that hit us last year. So what we ended up doing is, for one of our construction clients that formed their disaster recovery division recently also, we started capturing a whole bunch of different buildings, whether it's large hospitals, schools, government buildings. We've done all that with the mobile scanner, the NavVis VLX devices that we have. And we captured, I believe, somewhere around like 15 buildings or so in 12 days, just straight working, doing capture. I mean, because we had no power, I guess nothing to do, no work, right? So we might as well do something with it. So it turned out we got additional contracts from that, and currently we're waiting to hear for the hurricane that hit last week, Hurricane Ian. So we might be deployed to Florida pretty soon. But you can capture, the buildings for the post-disaster assistance, but also from the insurance standpoint, you can capture it pre-loss to do the pre-loss assessment. So other markets that we're currently exploring or in are forensics, accident reconstruction, medical, situational awareness, whether it's a fire that the fire department needs to use a digital twin, or if it's an active shooter type situation, which not fun to talk about, of course. So those are the things that we're exploring or we're currently in outside of what we have. Some project examples. So for the industrial example with the metrology-grade scanner, I used the offshore silencers that we scanned. So the metrology-grade scanner, again, with the high accuracy of 9 10,000ths of an inch. What we had to do for this specific job is the client is an offshore platform. They needed the silencers cleaned, so they shipped it to a company that we work with. They cleaned it, sent it back. They were not satisfied. There was a whole bunch of carbon smoke that came out. They shipped it back again. So the shop contracted us to go scan before they cut the valves at the flanges on both sides of these silencers. We had to scan everything. They cut the valves, cleaned the internals. We scanned again after they rewelded everything. So we compared pre-weld, post-weld scans, overlaid them together, created a bunch of drawings for them, giving them dimensional data. And you'll see in the probably next frame the overlay image of the data. So then these reports were emailed to the client. There we go. So blue is from the original scan, the pre-weld, and the magenta one or the purple one is the secondary scan after the post-weld, after the weld. So you can see the slightest differences with the metrology-grade scanner that you wouldn't be able to see with any other type of device. Again, takes the longest amount of time, right? But you kind of get what you pay for, you're waiting for in this case. Here is a good use of terrestrial scanners. It's building scanning, sure, but also historical tax credit type scans for the architecture construction industry. This is a hospital that's been abandoned since Hurricane Katrina, 2005 in New Orleans. So the client, they were getting the tax credits from the local government, so they had a certain accuracy requirement to capture these buildings, or it's the building, I guess. So we captured the entire exterior, rooftops with terrestrial scanners, and we delivered it to the client using web viewers, utilizing web viewers, plus the recap in multiple different files, so they could do their designs based off of these. So again, old building that has been, basically, it's been abandoned for 17 years at this point. And it's just the conditions keep deteriorating, so we had to capture it. They kind of started doing their architecture, all that from those scan data. So I'm going to go a little forward over here. All right, for another use case for mobile scanner is refinery unit scans. So in the industrial market in refinery scanning, the VLX is a great tool, and that's one of our scan techs, Taylor. So VLX is a great tool to capture the overall site or unit scans or unit area. So we scan a bunch of small to large units within multiple different sites. all data is registered over the cloud, turned over to the client with the IBM web viewer. And after that, we can take that data and upload it into other platforms like Syn2VM or whatever else the client wants for whatever program they want to use. From there, we can tag the critical equipment. That way, the client, if they send it to a contractor saying, this is the area that we want you to work in, it is equipment 1, 2, 3, ABC, they know exactly where that equipment is located. So the walkthrough of the refinery, you can basically provide it for turnaround planning, maintenance, inspection, design, all that. It has multiple uses throughout the refinery. So it's not just the point cloud, it is the walkthrough that comes into play with this too, especially in the planning phases of a project in any refinery. All right, here's the web viewer, Ivion. As you can see, you can walk around. It's sort of like Google Street View. Those guys were presenting earlier, so I'm not going to go too deep into this. But measurements, annotations, tagging, all that are functionalities that you can do within this without needing the actual point cloud or any special software. All right, so architecture construction, building scanning with the NavVis, the mobile scanner. So this is not the image for that, but it's, we basically captured multiple buildings. One of the stories was that recently, one of our clients, they were closing on a building. It's a $20 million project. They needed floor plans. So it's an 11-story building that has, I think, over 150 condos. So we scanned every unit, every corner, anything and everything within that building within 3 days, and turned over floor plans of the building with section data and all that within 10 days to them so that they could close on the building. Unfortunately, the closing got postponed, but not because of us, so at least the data is turned over. In this case, it's this one's a French Quarter building, so historical building, again, multiple units, and this was scanned in 45 minutes with the NavVis VLX. So, and we modeled it, overlaid it with the scan data. Here's the model. As you can see, we can cut through different sections and using NavVis, which is a cool animation tool. All right, I'll move forward. So here's one of those disaster recovery assistant type scans that we did last year. So this is an Ochsner brand hospital. It's a big hospital chain in Southeast Louisiana. So what we did was we captured the critical areas of the hospital on the first floor, which is basically the surgical suites and additional admin-related areas. This took us 1 day. But we captured some rooftops as well to see if there are any damages on the roof levels, so that if there's any leaks on upper levels, they would know why or where, how to pinpoint it. So all this was turned over to the clients typically the next day. As soon as we could upload and process it, we were able to. So the delivery of this to the disaster recovery client, but what it did was they could tag every object that was damaged or every area that was damaged, and in turn get the hospital, I guess the higher ups, to get the mitigation process started to get the hospital back in action or back in service, typically. So as you can see, it's like a maze. It's a bunch of different rooms, areas that you go in from one, come out from another door. But all this was done within 1 day using the NavVis scanner. All right, drones. Drones have also a huge, use case. It's multiple different use cases. There's typically multiple different types of drones as well. So I'll leave it as general as possible. It can be used for inspection purposes in architecture, construction, industrial, or disaster recovery assistant type stuff, type jobs. So in this case, one of our clients in disaster recovery, this is a government building. They wanted us to inspect their roof. So the first floor of the building is all captured with NavVis. The roof area, we did capture with NavVis, but we also did drone capture as well. And it's just, that was enough for them. So we turned over the data using IVN again as the web viewer. And they were able to see if they have some damaged areas on the roof. The thing to pay attention with drones typically goes down to the accuracy. So again, if the client is comfortable with having a certain amount of accuracy, in this case, over 300-foot long or wide roof, it was off about 5 feet. So if they're okay with that dimensional data, drone is going to be your fastest approach to capturing this. So another drone use is not the image that you're seeing or not the video that you're seeing. That is Google Maps overlay, but we're currently working on a case. It's been dragging for 2 years. It's a lawsuit, right? So the client required the accident location to be captured with drones. So we captured that. We had the police report, so we animated the entire accident. And it's similar to this. So the animation that shows basically how everything happened to the point of you even put in the speed data and anything else that's attached to that report. You deliver it to the client. In this case, it was a lawyer. So they're currently still waiting to settle and not, they don't want to go to court. But in these type of cases too, drones can be very helpful, and it's the fastest type of capture. Accuracy, not that important, right? Another use case for drones in the industrial, confined space inspections. So internal inspections of a vessel is a requirement, right? They have to do this on a periodical basis or when there's a problem. So in this case, we were required to capture internals of a vessel. So since the diameter of the vessel is too small, it is risky to send people, basically build scaffolding, put the people in there. It is a risky situation. It takes a lot of money, a lot of time also. So sending a drone that is capable of flying in confined spaces is the key to capture something like this. In this case, we used an Helios 2 drone. So we were able to send it up there, capture everything in video and image format, and deliver that to the client. So, right, additional use cases and testing efforts. So we as a company, we love testing the tools that we currently have at different environments with different tools also, or different platforms, and also testing new and shiny tools as well, right? So some of our recent testing and future testing, we put it down over here. So for the NavVis VLX, we've actually tested it using man lifts, not only going up and capturing an elevated area, but also using the man lift to go around the refinery unit. So that was a little challenging, but it worked out still. Same thing, so the image on the top is the man lift basket. The bottom image is the NavVis VLX held upside down. Basically, we rigged it to attach it to a crane. So that is something that we will try in the next few weeks, months. So another trial that we're gonna try actually was supposed to be this week, didn't happen. I'm still pushing for that, but we want to put the VLX on a boat, on a person, on a boat, and bring it to the docks to just capture dock area for a client. The looping and all that is going to be challenging, but at least, we had to try to say, no, it doesn't work, or yeah, it actually works, we can't use it for this. So drones, some of the new stuff that we want to test out is coastal restoration. So as we all know, in Louisiana especially, we lose a lot of land per year. So we want to sort of keep tab on that. And a lot of companies do that, but we want to go into that space and explore it. Submersible drones for clear lake or any clear water type inspections. This is the tool that we want to use. So in some cases, bridges or other infrastructure, it can be inspected by these type of drones. pipe rack inspections has been something that has been done, so it's another use case for some of the drones that we have or we might purchase in the future. Post-disaster general neighborhood or area capture. So if there's a hurricane like the one in Florida last week, if we have multiple crews that can send drones into different neighborhoods, because that assessment process takes way too long, it's been taking over a week, 10 days for our clients to basically assess the damage and say, these are the buildings that require some additional services, right? Drones would make that a lot faster. We can just go capture just general roof buildings in different neighborhoods or areas, and you can say, this one is damaged, this one is damaged, this area is good. So something that, unfortunately there has to be another disaster to test this, but yeah, it's something that we will look into. So here's a little flowchart that we created. Not all of our clients or all the people that we talk to understand the differences between the panoramic picture or the photogrammetry and the point cloud. So in this one, and this is something we created for the mobile scanner, but this goes with the terrestrial capture too. Anything that has a panoramic image embedded with a point cloud data. So your top path gives you the point cloud that is brought into any CAD software for design. Then you get your 3D model if you're interested in getting a model, right? So that is your final deliverable. The bottom path, or the secondary product, in this case, is panoramic imagery, which is, it gives you photogrammetry, which allows the client to view everything through web viewers. Basically, it is the virtual walkthrough aspect of everything. So it is a good little slide to show them, look, you're getting two different things. One is used for design, the other one is used for virtual walkthrough. So, all right, conclusion. There's always a right tool for the right job. Sometimes multiple tools can be used together. So you got to merge the data to get the overall, product, which is what you deliver to the client. And not every reality capture device fits the job requirement and scope. So you have to pick and choose which ones are better for this, which ones are better for the other job versus, and that comes with the client as well. Clients sort of, this is what I want, this is my job scope, and this is how I want it. So that's it. Thank you all.